So we are continuing with the second question now. This one states, what is the reading of this resistance thermometer when the reading of the mercury in gas thermometer is 80 degrees Celsius? Now we may assume that the two thermometers are where the fixed point. Now first of all, we need to know what the fixed point, and from the slide and the textbook we know that the fixed point of most thermometers is actually the boiling point and the freezing point of water, which is what, 100 degrees Celsius and 0 degrees Celsius. Now from the first question, we know that we have the now from here they're telling us to calculate what the temperature of the resistance thermometer will give us when the mercury is reading 80 degrees Celsius. Now since we know that the reading of the resistance thermometer will depend on the resistance of that thermometer at that point, like the temperature in which the resistance thermometer will read will indicate will depends on the resistance, and that resistance will depend on the temperature in which the mercury since the resistance in which the mercury thermometer read, since the resistance of this thermometer depends on the temperature. So from there we know the resistance of the substance at 100 degrees Celsius from our previous question was what, 0.667 R0, and that at R80 is equals to 0.757 R0. Now we also know that the temperature at R0 is equals to R0 automatically. Now from this, so we know the resistance of this point. Now we're asked to calculate the temperature which will be indicated by this resistance. Now in order to do it, we know the secondary school method of calculating temperature. Sorry, I have to clean the board from here so from here we have this. So now the method we use to calculate temperatures of different scales is using this something like this, so that we map out different temperature scale. Now from here we know that the resistance at 100 degrees Celsius of the substance in the resistance thermometer is at 100 degrees Celsius is 0.667, right? And that at 0 degrees Celsius is equal to what, R0. Sorry, let me make it bolder. So 100, so that's 0.667 R0, and at 0 degrees that's going to be R0. Now we'll ask to calculate what the temperature this will give us, like the impression of the temperature in which it will read, like what perspective of the temperature will this resistance thermometer give us. So from there we know the resistance at 80, we calculated that in the first question. The resistance at 80 degrees Celsius of the resistance is what, 0.757 R0. So we are looking for X, or let me just name it T8 for simplicity. Now so all we just need to do is, from here we know that we can, if we take the difference of this divided by the difference of this, it's going to be equal to the ratio of the difference of this and the difference of this. Like the ratio of this difference and this difference is equal to the ratio of this difference and this difference. You understand? So from here, taking the ratios, now you can actually choose any of this, any ratio, any two pair. You can choose any two pair as long as the pair you take here is equal.